Hello, everyone. Welcome back. This is chapter 3, section 1. This one has 45 slides, so hopefully we're able to get through this section. But for this it should go pretty quick. Measures of center is something that you've seen in the past. Measures of center, we focus on the mean and the median. So how many of you have seen the mean, the median, and the mode and things of that nature, right? So measures of center we'll start with is the definition of the value of the center or the middle of the data. So that it would be your median, what happens, where is the location of the center of the middle, okay? So the center, we're gonna have to look at the median. What happens at the median value? The mean, the arithmetic, so there's a difference. So what we're gonna be doing in this class is finding the arithmetic mean. So it's the mean of set measured of center by adding the data values and dividing them by the total number. No, Luis, we didn't get disconnected. It's just that I closed the Zoom session and then I opened a new one so then I can have a new fresh recording. Yes. So hopefully everybody's here. So on this section, we're going to be looking at the median and we're going to be looking at the mean. Be careful. So mean in this class is not represented by the average. Referring to the measure of center, the word average is often used for the mean, but it's never used for measure of center. We just don't use this verbiage. We don't use the word average. We just stick with the word mean. The term average is not used by statisticians or community of professional journals. So for example, when you read a statistics paper, you're not going to be looking at averages, you're going to look at mean values. That's what this is saying. What are the important properties of the mean? Sample mean, so be careful. We have two different types of mean. We have population mean and sample means. In this class, we will always get sample means before we get even a population mean. Remember, the sample or the statistic is just a smaller portion of the big population. So we do studies on smaller portions than the whole spiel. So sample means are drawn from the sample population tend to vary less than other measures of center. The mean of the data uses every data value. The disadvantage of the mean is that it's just one extreme value, and an outlier, this is the most important thing. An outlier can change the value of the mean substantially. So therefore, that means that the mean is non-resistant. So it doesn't it doesn't resist when an outlier comes into play, where the median is. The median is resistant. So it doesn't matter if you have an outlier, the median is still the middle number, regardless of the outlier. Whereas the mean, when you input an outlier, that messes up, that interferes with finding the true mean. Okay. What does it mean to be resistant? Statistic is resistance if a presence of an outlier or an extreme value does not cause it to vary very much. So the mean is non-resistant. The median is resistant. What is the formula of finding the mean? Don't be scared. This is just the sum of all of the data values and is the number of data values. So for example, if I have 1, 3, 5, 6, 8, 9, to find the mean, how would I find the mean of this? I would have to add 1 plus 3 plus 5 plus 6 plus 8 plus 9 all over how many data values? 1, 2, 3, 4, 5, 6 over 6. And then there it is. And then I would find the mean. And this is called the sample mean. It's X bar. Let's write these notation. You need this because in your homework, you're going to see this again, and I want to make sure that you understand notation. Okay. So there is our sample mean, and then we have mu that's represented by population mean. So what we have on this part is the X bar because we're looking at a particular sample. Okay. The notation again, this is summation. That means the sum of the data values. This is just a sum. X is the variable represented by the individual data values. N is the number of data values in a sample. Big N, there's a difference between little n and big N's. The little n's represent a sample, big N represents population. Okay, so we'll see that. So just making sure you understand notation. Notation matters. There it is. We have X bar. That is our sample mean. Look at the difference between these two. What is the only difference that you see? The n's. One is the little n, that tells us it's a sample. Big N tell us is the population, and also the X bar and the mu. X bar, sample mean, mu, population mean. And this is being recorded. So in case that you miss something, you can always go back and check. Let's look at this one. Let's calculate the mean. I'm going to show you that there is, if you want to download this for your own sake, I recommend you to do that. So there's a way to do it on your calculator super fast that tells you everything, or on Wolfram Alpha. There's a lot of resources because this is an online class and a hybrid class. You're more than welcome and encouraged to use your tech devices. So the data set, Disney World time wait. So this is the time it takes to ride for 6 popular rides. Find the mean of the first 11 wait times for Space Mountain at 10 a.m. So how do I find the mean? Remember, this is X bar. This is the sample mean because we're only grabbing a sample. We're only grabbing 11 wait times. So X bar, it's going to be the sum of your X values over N. So we know N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the sum, we have to add 50 plus 25 plus 75 plus dot, 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 dot. I'm going to show you on a calculator. If you have a graphing calculator, a TI-83, a TI-84, or on, I have something called Calculate 84 installed on my Apple computer, on my computer, and I want to be able to show that. Let's see if I can. It looks like this. Do you guys all see the calculator? It says Calculate 84. So I'm going to clear this. I'm going to go to second quit. Oh, second quit. And it's going to look like this. So what I'm going to do is I'm going to list the values. So I'm going to go to, let me clear it. Second should be, sorry about that. I want to clear the whole thing. So do you guys see stat, everybody? So stat, and then I'm going to click on edit. I'm going to get rid of these values that I have here on these two. Let me get rid of those. And so I just click on it and then put delete. So my L1 will be the values of 50. So I'm just going to put them in 50, 25, 75, 35, 50. So again, I downloaded this Calculate 84. It's for free. It's a graphing calculator. So 50, 25, 75, 35, 50. Then I have 25. Then I have 30. So 25, 30, 50, 45, and 25, and 20. So that's my list. L1 is the data that I'm given. So then I'm going to go, I'm going to go to vars. So I'm going to go to stat. So again, once I put in the data, I'm going to go back to stat, calc, one vars test, and you're going to put L1 and then hit enter. Notice that you see here, it tells you pretty much, there's your, so if you scroll up, 39.09, that's your sample mean. That's the sum of your values for 30, the standard deviation right here. The quartile 1, quartile 2, the median, it tells you everything. So that's why I'm showing you how to do this on your calculator, because it's gonna tell you everything that you need to know. Any questions on that? So I'm gonna go back to my notes. So that we saw that there's our mean, 39.1. You could have just done this on your calculator as well, add and divide it by 11. You could have done that too. The median would be the middle number. The way that you would do this by hand would be to actually reorganize. You have to put the order in an increasing order. Okay, so for that one, we start low. So in this case, we need to reorder the data. So first we have the 20, then we have how many 25s? 1, 2, 3 25s. So 25, 25, 25. And then we have how many 30s? We have 130, 135. I think that's it. And then 45. And then 250s. Oh no, 150, 250s, 350s, 50, 50, 50, and then 75. Let's count if that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Now you do cross, cross, cross. Oh, this one didn't cross. Cross, 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 cross. And then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our middle number is 35. That's our median. We found the median automatically using our calculator. Again, that's our median. So what are the important properties? The median does not change by large amounts when it includes just a few extreme values. So the median is a resistant. We saw that. We talked about that. So regardless if we add outliers, your median will stay the same because you're still in the middle. The median does not directly used in every value. So what we use the most is your mean, actually. So this is just your measure of center. When we're calculating the median, it's found by x tilde. Okay. If the number of the data is odd, then it's exactly the middle number. If it's even, then you're going to take the mean between two numbers. So instead of having 11, you have 10, you would end up with two middle numbers in the middle. So you add them and divide by 2. Any questions on finding median of datas? Questions on the chat? How do we feel? So far, so good? So you want to have those nodes for the calculator 84, so then you're just able to find everything on one single shot. So look at this one. So these are, we found the median. We found that the median was 35, right? We did that. We sorted the values from smallest to greatest. And we said cross, and then we said cross, 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 cross. There's the middle. So what happens when we have now 12? So we have one more. So what we do is reorder the data. So now we will have 20. And then how many? 1, 2, 3 25s. And how many 20s did we have? 1. So we have 25, 25, 25. We have how many 30s? We have 130. How many 50s? 1. Oh, before 50, we have a 35. 30, 35, and then how many 50s? 1, 2, 3, 4. So it's 50, 50, 50, 50. Should be 1, 2, 3, 4, and then 75. And then we play that game again. There's a 45. Oh, I'm missing one. Thank you. So see, that happens. So 35, and then there was 145 right here. And then how many 50s did we say? 1, 2, 3, 4. 50, 50, 50, 50, and then 75. Now, then we play that game of cross, 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 cross. I crossed 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I see two middle numbers, not one, because this is even. Now what happens? I'm going to add 35 plus 45 and divide it by 2. What do I get? What's 35 plus 45? Oops. That's 80. 80 divided by 2, that's 40. So then see how my mean will change, my median will change. So the median will change if I have odd or even. So be careful there. Okay. So there it is. You put it in order, you sort it, and you get 40 minutes. Okay, any questions? You could have done this on your calculator, so input the values. And the good thing about your calculator, you don't even have to put it in order. You just tell what it is, and it will tell you the mean, the standard deviation, the variance. We're going to talk about that in a moment. But the good thing is that we already know how to do it. We talked about the mode. A mode is something that we've seen already a few times. So mode is just which one occurs at a major frequency. So the mode can be found in qualitative data. A data can have no mode, one mode, or multiple modes. So this is special. It can have no mode. So let's say if I have 1, 3, 4, and 5, none of them repeat. So this would be no mode. If I have one mode, so 1, 1, 3, 4, and 5. Well, the mode is 1. 1 is the mode because that's the one that repeats it the most. So it's only one mode. Multiple modes would have like 1, 1, 3, 3, 4, 4, and 5. Which ones are my modes? 1, 3, and 4. All those 3 are my multiple modes because they repeat themselves the same amount of times. That is a multimodal. That means there's more than one mode. So far, so good, everybody? Okay. Finding the mode, again, a data set can have one mode, more than one, or no mode. When two data values occur with the same greatest frequency is one mode, and the data is called to be a bimodal. Okay. So for example, well, this one doesn't have a bimodal, but it would be like 1, 1, 3, 3, and then 4 and 5. This is called a bimodal because we have two modes that occur with the same frequency. Then we saw the multimodal, 1, 3, 4, that's a multi. And then no mode is the 1, 3, 4, and 5 because no one repeats. So that's a no mode. So let's look over here. When we saw this, we saw that 30 repeated it 2 times. 30 repeats 2 times, 35, 3 times. So 2 times, 3 times, and 2 times. Who wins? 35. It's a one mode only. Because the 35 shows with more frequency, 3. This one wins. So 35 is my mode. Now here, this one has 2 modes, both 30 and 50. And no mode is 20, 30, 35, 50, and 75 because no value is repeated. Okay, something that we already went over, but just with a proper example. Any questions with mode, mean, median, mode? Again, this section, section 3, chapter 3 is just something that we've seen already. Nothing, not hard rocket science. This is a new one, probably a mid-range. So the mid-range of a data is the measure of center where you're finding the midway between the max and the min divided by 2. So the mid-range is you're adding the highest value plus the minimum value divided by 2. So that is called the mid-range. So let's write that down. Remember, when you're doing your homework and you're doing your quiz and your final, make sure you do have your notes with you. You're not expected to memorize nothing, not a formula whatsoever. So it's nice to have them when you're performing your homework. So just having them with you. What is mid-range? Because the mid-range uses only the maximum and the minimums, this one's very sensitive and this is not resistant. So the mid-range is non-resistant because it can change dramatically. So if my maximum value changed because I had an outlier, then that's going to affect, of course, the orientation or what I'm looking for. Okay. What are the important properties of mid-range? Why do we use a mid-range? Because it's very easy to compute. You only grab the max and the min and add them and divide it by 2. It helps you reinforce the important points that there are several ways to determine the center. The value of the mid-range is sometimes used incorrectly. Be careful. This is not the same as the median. Okay, they're different. The mid-range is helping us another way to find a particular value in our data. Okay, it's not the median. How would we find the mid-range on this example? So we know 75 is the max. The min is 20, so we would do 75 plus 20 over 2, 95 over 2. Okay, and that gives us 47.2 47.5. Notice that this is not the same as the median. What was the median for this data? I think it was 35. So notice that they're not the same, that this is the median. The median and the mid-range are not the same. So be careful there. Okay. A round off rule for the mean, the median, and the mid-range. You carry one more decimal place than the present. Sorry. So then here, if we're looking at a particular example, we usually round one more decimal place than the original. So let's say that my values are whole numbers. So then my median, my mean, and the mid-range will be 1.1 or 1.2. So we're going to round one decimal than what it is on the original. For the mode, we will not round. These are called round-off rules. This is what we see a lot of in statistics. We usually round 1 or 2 decimal places, depending on what we're being asked. Okay. So critical thinking, we can always calculate measures of center from samples of numbers. We will always think about whether it makes sense to do that or not. We should also think about the sampling method used to collect the data. Remember, we saw different types of data. Some data that are even not meaningful. So whenever we're looking at different studies, when we're finding the mean, the median, and the mode, we want to be sure of what we're doing makes sense to us. Okay. So what is meaningful is if we're looking at this scenario. See the following illustrated situations in which the mean and the median are not meaningful statistics. Well, here, first of all, what they're giving us is something categorical. The zip codes is something categorical. It's not quantitative, it's qualitative. So be careful. So they're just giving us numbers, but zip codes don't measure or count anything. Okay, they're just labels for geographic. So again, these are categorical. What we're focused on is quantitative. It's actually measures that will give us something that have meaning. Again, here, ranks, the rankings. Okay, we talked about the fact that so we're looking at different colleges, rankings of colleges, of universities, which is also categorical, but a different type. These are still categorical. They don't mean anything. They're not quantitative. And we talked about this, measure it's at a nominal level, right? So there's nominal level, there's interval. We talked about that as well in chapter 1. Now, also again, look at this, even just looking at the question, numbers on a jersey. Jersey numbers are not meaningful. These are, again, are categorical situations. Things that you can put labels, that if they're going at a particular order, that does not mean anything for us. Top 5, again, the top 5 does not mean anything to us, okay? It's not represented, it's just giving us a particular small scenario where the results will not have meaning because these are already predetermined top 5. Okay, so we're not learning anything new. Okay. So look, what about this one? The 50 men ages computed from the means in each of the 50 states. So then here, the population sizes of 50 different states must be taken into account as described in the mean. So for example, this one, so you're already given the means of the data. So that you're finding the mean of the mean or the median of the means. Okay, these are predetermined scenarios that were given, that they are not meaningful for us in our statistics. So what we're going to do in the next part is calculating the mean from a frequency distribution. Can we do that? Absolutely. And that's the whole point of what we're going to do next. We're going to be calculating the mean from a frequency distribution. So the way to do that is we're going to be using this formula. It's not the same as your usual mean, right? Because the data that we're given, it's not the same. We're going to be using the frequency and the class. So we're going to use the value of the frequency, F. F is your frequency. And X are the values. And then we're going to have the sum of the frequency. But we know that this is the cumulative. We know that this is the total value. That's like our N, the total number of values in the distribution. So we're going to find the mean of a frequency distribution next. And we'll do, that's going to be the last thing we'll do. And then we're going to go on a minor break. Okay. So this is what we have. So what we do first is we first calculate, so X is the midpoint. Let's write that down. So remember how we found the midpoint of each class is add divided by 2, add divided by 2, add divided by 2. These are the midpoints for each. So to do that, we're going to do 6 times 7. 6 times 7 is 42. 18 times 22. 396. 14, how did we get 14? That's our frequency. So all we're doing is we're looking at F and we're looking at the midpoint and we multiply each one. 14 times 37, 5 times 52, 5 times 67, 1 times 82. And these are the midpoints for each of the classes. 75 plus 89 divided by 2 is 82. 90 plus 104 divided by 2 is 97. So we multiply across, and then we're going to add all of these together. The sum between the products is going to be 1,730. So we're going to use this part and divided by this part. So to calculate the mean, X bar, it's going to be 1730 divided by 50. And that's going to give me my mean of the frequency distribution. Okay. So just step by step, the midpoint is from your class widths, the midpoint. So from 0 to 14 divided by 2, 15 to 29 divided by 2, 30 plus 44 divided by 2. That's how we get the midpoint. And then we take the midpoint and multiply it by the frequency. So let me rewrite the top. So my X values is the midpoint. So I'm going to find each midpoint and I'm going to multiply it by the frequency. Okay. So that's what we're going to do. There it is. So that is just finding the mean. There is something called the weighted mean. The weighted mean has a different formula. W is the weight. each weight is a different value. So for example, when you're looking at letter grade, they have weights, they have points multiplied by X, which are the data values, added by the sum of the weights. So let's look at this. This would be the last example. In her first semester of college, a student took 5 courses, her final grades along with the numbers. So she got an A that represents 3 credits. So that's the weight. B is, so she has A with 3 credits, 4 with 3 credits, B with 3 credits, C with 3 credits, and F with 1 credit. So those are the weights of each, okay? The letter grade, so A is 4 points, B is 3 points, C is 2 points, D is 1 point, and then F is 0 points. Okay, so what we're gonna do is put them next to each other. Look at the weights, 3, 4, 3, 3, and 1. The weights corresponds to the credits. Then we have the assigned. So we had a 4, a 4. Why do we have 4, 4, 3, 2, and 0? Because she got 2 A's, 1 A and 2 A's, 1. So the 2 A's are here, 1 B, 1 C, and 1 F. So then what do? We multiply, so we have to first find the sum of the weights. If we add 3 plus 4, that's 7, 10, 14. The sum of them is 14. And then we're going, so that's the denominator, and we're going to take the weight times the X every time. So we're going to do 3 times 4 because that's for the first credit, the second credit, the second A, the third credit with the C. Okay, so she got a B, and then there's a C, and then an F divided by the 14. Okay. So in this case, she earned a 3.07 GPA. Okay, and that is called the weighted mean. So again, over here, 4 times 3, 4 times 4, 3 times 3, 3 times 2, 1 times 0. Do you see the multiplication between them? Okay. Okay, there it is. 3 times 4, 4 times 4, 3 times 3, 3 times 2, 1 times 0. Okay. And that is called the weighted mean. So she received a 3.07. We round that to 3.1. Okay, that's the usual weight point average. So that is going to be the end of this lesson for right now. We are going to go on break. It is 7:45. So let's resume class at 8 p.m. I'll open the session again. I'll stop the recording now. And this is, of course, section 3.1. We still need to do 3.2 and 3.3. And that's going to be the end of this lecture. Any questions? All right, I'll see you guys in a few.